Hello, this is Mario from Audion. In this video, we will explain Audion's Material Calculator, which is available in Editions Auditorium and Combined. The Material Calculator is a new feature in Audion 17, which allows you to create materials in the material library by defining a stack of layers, such as porous layers, perforated layers, and membranes, each layer with individual parameters. Audion will then calculate the absorption coefficients of the full stack, and you can save these coefficients as a material. However, notice that the absorption curves look continuous, and that you can also display other curves such as the complex surface impedance. So, the material calculator can be applied for purposes other than room acoustic simulations, such as education and research. You will find the material calculator when creating a new material. So, we will first go to the material list. Before creating the new material, you might want to already know the material number you will assign to it. Additionally, make sure whether you're adding it to the global library or the local library. We will then go to Add Material. And here you will find the Material Calculator tab. There will be a default backing layer which cannot be removed. And this backing can either be rigid or air. The rigid backing is for materials placed on a wall, so it is used most often. The air backing is used for cases where there is an opening behind the material, as is the case with windows or curtains. Just keep in mind that in this case, the sound that would be transmitted in reality will instead be modeled as absorbed. So, if you wish to model the transmission, remember to manually configure the wall type as a transmission wall. Let's add a new layer. By default, a porous layer is added, which is used to model materials such as mineral wool or glass wool. This cross-section will show your current stack, in the same order as the list. Also, now we can see the absorption curve for the current stack, which in this case is only a porous material on a rigid backing. Here, you can change the name of the layer. And you can change the layer thickness in this column. Each individual change will immediately update the absorption curve. For example, if I hold one of the buttons here, you can see the curve changing shape. In this section, you can specify the properties of the selected layer. For porous layers, only the flow resistivity needs to be specified. Let's look at some other layer types. The fluid layer can be used to represent lossless media. There are presets for air and water. Or you can define a custom density and speed of sound. Be aware that an air layer will be ineffective if placed at the end or in front of an air backing. For a perforated plate, you can define the hole diameter and the perforation ratio. You will also see a diagram of the configuration. You should not have the perforations overlapping. So, if your perforation ratio is too large, it will automatically be adjusted to the largest possible value. For a rectangle slot plate, you can define the slot width, slot length, center-to-center width distance, and center-to-center length distance. The plate's perforation ratio is automatically calculated and displayed. You can also have the slots be infinitely long. These are usually referred to as slits. For layers with either circular perforations or rectangle slots, the plate itself is assumed to be perfectly reflective. Finally, we have the membrane material, which can be used to represent thin impervious sheets or vibrating plates. The equations used are mainly for thin sheets. The main properties to define are the density and the Young's modulus. This will also display the mass per unit area and critical frequency with the current settings. As more advanced settings, you can also define the Poisson's ratio and the internal loss factor. This type cannot be selected in front of a rigid backing. If your backing is air though, it will be available to select on the first layer. You will find some guidelines of material properties on the context-sensitive help, which you can access by pressing F1 and will show help relevant to the active window. For example, if you press F1 while in the material calculator, you will find how to estimate flow resistivity from density and fiber diameter, and the properties required for a membrane layer of a few real materials. Notice that each layer type will have a different pattern in the cross-section. The rigid backing has diagonal lines. Fluid layers have a single solid color, which is white for air, blue for water, and green for custom. Porous layers have a crisscross pattern. Perforated plates and rectangle slot plates have vertical lines. And membranes have horizontal lines. Here, you can specify whether you want to calculate the absorption based on an infinite panel or a finite panel. If calculating a finite panel, keep in mind that the stack is assumed to be surrounded by a rigid baffle, so free-hanging materials currently cannot be calculated. For a finite panel, a rectangular shape will be assumed. We recommend to calculate either for an infinite panel or for an area larger than 10 square meters, as suggested for absorption measurements in a reverberation chamber. These recommendations are because Odion automatically calculates scattering due to diffraction during the simulation. By default, this curve shows the random incidence absorption coefficient, which is the absorption used in Odion. For all curves, you can toggle a logarithmic scale for the x-axis. And you can display the 1/3 octave band average values, though remember that these won't be used in Odion. You can also look into other types of results by clicking here. The layer properties are the only results associated to individual layers, as the other results take into account the full stack. For most layer types, you can see the characteristic impedance and the propagation constant. While for membrane layers, you will find the layer impedance. For properties expressed in complex numbers, you can enable a Nyquist graph view. This shows the real part in the x-axis and the imaginary part in the y-axis. You can change to a different layer here. Aside from the random incidence absorption coefficient, which we have already looked at, the other available results are the surface impedance, radiation impedance, reflection factor, and the angle-dependent absorption coefficient. These four properties are angle-dependent, so you can enter an angle of incidence over here. The angle will show in the cross-section as a blue arrow. Keep in mind that this angle-dependent absorption will not be used by Odion during calculations. The absorption coefficients of materials in Odion are meant to be the random incidence absorption coefficients. So, when using the material calculator, Odion will use the absorption values from the random incidence absorption curve. Odion does calculate a certain degree of angular absorption during simulations, but this is derived from the random incidence absorption coefficients. Aside from adding layers, you can also delete individual layers, move them up and down the list, duplicate them, or clear the full stack. If you enable AutoFit, the vertical zoom of the stack diagram will be adjusted automatically after each change. The blank space is for the angle of incidence arrow. Now, let's save this stack as a material to use in Odion. To do that, click on this button, Transfer Absorption Data to Material. You will see the absorption coefficients entered down here, which will be the octave band average values of the random incidence absorption curve. Depending on the values, you may get color-coded warnings. Absorption coefficients below 0.05 or above 0.95 may be unrealistic. So, coefficients below 0.05 will be highlighted in blue, and coefficients above 0.95 will be highlighted in red. A field highlighted in yellow means that the value is different from the calculated one, which may have been caused by different reasons. One reason is that the value was manually modified by the user. The other is that the value was below 0.01 or above 1, and it was truncated to those limits as suggested by Odion. Finally, we will enter a material number and a material description. The material will then be saved by closing the window and confirming. In the material library, materials created with the material calculator are highlighted in blue. In general, you can go back and edit any material, either by selecting it and clicking on Edit Material, or simply by double-clicking on the material. If you go back and edit the material highlighted in blue, it will still have the layer data available. So, you will be able to edit the layers. If you click on Remove Construction, this will delete the layer data. You will still keep the absorption coefficients, but you will no longer be able to edit the layers. So, the material will behave as a normal material. Conversely, you can also go into a normal material and add layer data. Just be aware that if you transfer the absorption coefficients, you will lose the previous coefficients you had on that material. In Odion's default global material library, you will find some examples of materials created with a material calculator, which you can open to view the layer data. You can also copy graphs and data for external use. You can click on either the cross-section or the curve, hit Ctrl+C to copy it, and paste it on an external software. You will also find some export options in this Options menu. You can either copy the absorption thumbnail, the currently selected graph, the values for the blue curve, and the 1/3 octave band values. You can learn more about the material calculator, such as the referenced research papers and equations used in the user manual. You will find it on our website odion.dk, Learn, User Manual, and go to chapter 4.5. With that, we conclude this tutorial, and we hope you have found it useful. Good luck!